Did you ever sit alone in a room and listen to your favorite instrumental music on high volume? Now, imagine you're walking in the traffic with the same music on. Will you be able to enjoy the sound quality? The answer obviously is no. But do you know why? Here we have a video to explain the reason behind it. We have already seen that the sound wave is a longitudinal wave. We can describe a sound wave by characteristics like 1. Frequency or pitch, 2. Amplitude, and 3. Sound quality or timbre. Here we can see the graphic form of the sound wave. When the sound wave moves in the medium, its density and pressure keeps changing. The change in the density can be shown simultaneously in the graph. Compressions are the regions where particles are crowded together and are represented by the upper portions of the curve in the figure. The peak represents the region of maximum compression. Thus, compressions are the regions where the density as well as the pressure is high. Rarefactions are the regions of low pressure where the particles are spread apart and are represented by the lower portions of the curve in the figure. Here also, the extreme point at the bottom represents the region of maximum rarefaction. Rarefactions are a region where the density as well as the pressure is low. A peak is called the crest and a valley is called the trough of a wave. The distance between two consecutive compressions C or two consecutive rarefactions R is called the wavelength of the wave as shown in the figure. The wavelength is usually represented by lambda. Its SI unit is meter m. Let's learn about frequency. Frequency tells us how frequently an event occurs. Suppose you're beating a drum. The number of times you beat the drum per unit time is called the frequency of the drum. Here, as we beat the drum 10 times in 1 minute, we can say that its frequency is 10 beats per minute. We know that when a sound wave propagates through a medium, the density of the medium varies between a maximum value and a minimum value. The change in density from the maximum value to the minimum value and again to the maximum value makes one complete oscillation of the wave. The number of such oscillations per unit time is called the frequency of the sound wave. From the graph, we can find that the frequency of the sound wave is 4 oscillations per unit time. Similarly, if we count the number of compressions or rarefactions that crosses per unit time, we will get the frequency of the sound wave. The frequency is denoted by the letter F. Its SI unit is Hertz. One oscillation or one cycle per second is 1 Hertz. The time taken by two consecutive compressions or rarefactions to cross a fixed point is called the time period of the wave. In other words, we can say that the time taken for one complete oscillation in a medium is called the time period of the sound wave. It is represented by the letter T. Its SI unit is the second. The frequency and the time period are related. Frequency is equal to 1 upon time period of the wave. Let's talk about pitch. Pitch is the sensation which determines the shrillness of the sound. The faster the vibration of the source, the higher is the frequency and pitch corresponding to that sound. Thus, a high-pitched sound corresponds to more number of compressions and rarefactions passing a fixed point per unit time. Simultaneously, the pitch of a sound can also be determined by looking at the graphic form of the waves. Here, the fast motion of the wave tells us that it is a high-frequency sound, that is, a high-pitch sound. We will now learn about amplitude. The maximum disturbance in the medium on either side of the mean position gives us the value of the amplitude of the wave. It is defined as the magnitude of maximum displacement of each particle from its mean position. It is represented by the letter A. Its SI unit is meter. Amplitude determines the loudness or softness of a sound. If we strike a table lightly, we hear a soft sound because we produce a sound wave of less amplitude. But if we hit the table hard, we hear a loud sound. Do you know why? In this case, the sound wave has larger amplitude and so it has higher energy. As a result, it produces a loud sound, which can travel a longer distance. Hence, the amplitude of the sound wave depends upon the force with which an object is made to vibrate. Let's learn about quality or timbre. The quality or timbre of a sound is that characteristic which enables us to distinguish between sounds having the same pitch and the same loudness. A sound of single frequency, as in the case of this tuning fork, is called a tone, whereas the sound produced by a mixture of several frequencies is called a note. We can see that both the sounds have different waveforms. Music is pleasant to hear because all the constituent frequencies are harmonically related. In comparison, a noise sounds unpleasant to our ears because its constituent frequencies are not harmonically related. Let's summarize. Compressions and rarefactions are the regions of longitudinal waves. The distance between two compressions or rarefactions is the wavelength and its SI unit is meter. The next characteristic is frequency, which is defined as the number of beats per unit time. Its unit is hertz. Time period of sound is the time taken for one complete oscillation and its SI unit is the second. Pitch determines the shrillness of sound. Amplitude is the maximum displacement of each particle in a wave from its mean position. Tone is a sound of single frequency and note is a mixture of several frequencies. Look at this musical keyboard. Did you know that the sound produced by every key is unique? What is the reason behind this uniqueness? Try finding an answer until we meet again.
Keep imbibing. We believe in you.